A fast thanks for joining me on Fascinating Frontiers, episode 62, coming to you on May 4th, 2026. Starting the week with the latest from space and science. Astronomers identified 27 candidate planets orbiting binary stars in distant solar systems. A Falcon 9 rocket successfully launched a South Korean imaging satellite along with 45 rideshare payloads into orbit. This mission underscores the increasing popularity of SpaceX's rideshare program for deploying multiple satellites at once. The efficient approach allows different groups to share the cost and capacity of a single launch. The South Korean satellite is set to provide valuable imaging data from orbit. The 45 additional payloads represent a diverse set of missions riding along. This kind of shared launch is proving to be a practical way forward in commercial space activities. The success of this launch shows that multiple missions can be accomplished together in one flight. It reduces the cost for each individual payload while still getting everyone to their destination. With commercial launches regularly expanding what's in orbit, NASA is releasing new data to support its own upcoming crewed missions. NASA has made public 12,000 images from the Artemis II flight. The images show the moon, Earth, and deep space captured during the mission. The collection offers fresh perspectives that will aid in refining plans for upcoming lunar explorations. With so many images available, researchers can examine the lunar surface and surrounding space in great detail. The Artemis II flight gave us new angles on our closest celestial neighbor. These resources are essential for preparing the equipment and procedures needed for sustained lunar presence. Having public access encourages broader participation in analyzing the mission data. The volume of images means planners can cross-reference different views to build a more complete picture. While NASA prepares for the moon, astronomers have identified new planets in much more complex stellar environments. Researchers have discovered 27 potential planets that orbit two stars simultaneously in remote solar systems. These candidates were detected by observing the subtle dimming of starlight as the planets pass in front of their hosts. Such findings help scientists understand how planets can form and endure in the complex gravitational fields of binary star systems. If verified, they would represent a significant addition to the known population of circumbinary planets. The discoveries would also provide new data on formation processes in multiple star environments. Observations like these push the boundaries of what we can detect with current technology. What unique challenges do these planets face in maintaining their orbits around two stars? The detection method relies on precise measurements of light changes over time. From distant worlds to changes happening on our own planet tracked through satellite observations, satellite data reveals the Hectoria Glacier in Antarctica retreated at an unprecedented rate. The glacier shed large volumes of ice in this recent event. This observation emphasizes the power of satellite monitoring to track and analyze swift environmental changes in polar regions. Ground-based measurements can miss the full scale of such rapid shifts. The record-setting retreat provides a clear example of how quickly polar ice can diminish. Continuous satellite observations are key to understanding these dynamic processes. The data helps quantify the extent of the ice loss in a way that was not possible before. As satellite capabilities monitor Earth, more nations are building their own space infrastructure. Tanzania has finished procuring the necessary components and services to develop its national satellite. Completing this step advances the nation's efforts to establish a presence in space technology and satellite operations. The first national satellite will mark an important milestone for the country. It will help build local expertise in satellite design, launch, and data management. Such projects often start with careful planning and acquisition of key technologies. The progress reflects a growing interest in space capabilities across more regions of the world. This acquisition sets the stage for the next phases of development and eventual deployment. National programs often begin with targeted research investments, including new NASA-funded studies. The University of Mississippi received NASA funding to investigate the properties and effects of space dust. Studying space dust is essential for developing better protection strategies for future spacecraft and crewed missions. Space dust can pose risks to equipment and astronauts during long-duration flights. The research will examine how this material behaves in the space environment. Findings from the study could influence the design of shields and habitats. This kind of targeted work supports the safety of upcoming exploration efforts. The properties of space dust need to be well understood before relying on new protection methods. Understanding the space environment also helps us appreciate the detailed views returned by long-operating observatories. Hubble has captured detailed views of ongoing star birth within the Trifid Nebula. The images were released to mark the telescope's 36th anniversary. These images allow astronomers to study the processes of stellar evolution in one of the galaxy's active star-forming regions. The Trifid Nebula offers a unique window into how new stars are being created. High-resolution data like this helps piece together the life cycles of stars. The telescope continues to deliver valuable insights even after more than 3 decades in operation. The anniversary release gives the public and researchers alike a chance to see fresh details. While major agencies advance their programs, commercial partnerships are opening new pathways for innovation. On a different note, new tools are letting amateur observers capture striking images of the night sky. An astronomer conducted the first test of the Dwarf 3's dedicated star trail mode. The test involves stacking 720 30-second exposures over 6 hours. You know what's fascinating about this? A 6-hour exposure captures stars sweeping exactly 90 degrees across the sky. This happens because Earth rotates at a rate that completes a full turn in 23 hours and 56 minutes. The steady motion of our planet is what turns those fixed points of light into long, sweeping arcs. Picture setting up a wide-angle lens pointed north and letting the camera run continuously. The planet's steady turn moves the sensor relative to the fixed stars, turning points of light into graceful arcs. Hotter stars burn blue-white, while cooler ones shine orange-red, with the colors emerging from their surface temperatures rather than any camera trick. In the test image, Polaris draws a small arc since it sits 0.7 degrees from the true north celestial pole. This method requires no special tracking mount, just patience and clear skies for the full duration. Over time, these trails can reveal the precise geometry of our planet's axis and spin. Yet the exact way atmospheric conditions and interstellar dust influence the visibility of those colors remains a puzzle that observers continue to explore. Imagine the stars painting long, colorful trails as our world turns beneath them. It's a simple yet powerful way to visualize the motion of our planet from your backyard. The approach opens up new possibilities for anyone with basic equipment and a clear view of the sky. Similar advances in consumer cameras are enabling sharper planetary imaging even under challenging conditions. Using a new ASI 676mm camera with a Takahashi telescope, an amateur astronomer produced high-resolution images of the moon. This was done despite poor seeing conditions. The results highlight advancements in affordable astrophotography equipment and the dedication of citizen scientists to lunar observation. High-resolution lunar images like these can reveal fine details on the moon's surface. The new camera technology is making it easier for enthusiasts to contribute meaningful observations. These kinds of captures show what is possible with modern but accessible gear. The images add to a growing body of work from amateur observers around the world. These examples show how both professional missions and individual efforts continue to expand our view of the cosmos. Thanks for joining me. Next time, we'll be watching for any confirmations of those 27 candidate planets around binary stars. That covers today's space and science news. Share this with a fellow space enthusiast if you found it interesting. I'm Patrick in Vancouver. See you tomorrow. And if you'd rather watch than listen, find us on YouTube at @Nara Network. Links in the show notes. This podcast is curated by Patrick, but generated using AI voice synthesis of my voice. The primary reason to do this is I unfortunately don't have the time to be consistent with generating all the content and wanted to focus on creating consistent and regular episodes for all the themes that I enjoy, and I hope others do as well.